Our next talk is Justin Hyatt, Getting Down to Earth, New Ground Station Technologies.
Oh, yeah, they're nice.
Okay, well, that up.
Those were in case.
Could I get some IT help really quick?
Is this your first?
This is it.
Okay.
Yeah. I'm actually. So I had some things prepared to talk about some of our capabilities and things like that, but listening to some of your comments, I thought it would be important to share a couple of different things. So is it possible for me to do an HDMI in?
To share different
To
slides.
put slides up?
I can, it'll be a little difficult because everything's running off of that laptop.
Okay, we don't have to do it. You can imagine in your mind, I'll describe to you what pictures I was going to show. But first of all, we've talked about already that this is a difficult time, that there are lots of uncertainty, lots of things going on. And that is absolutely true. But I also want to recognize that, and I think it's important that we recognize, while academic institutions across the country and across the world are biting their nails, and rightfully so, we here at the Space Institute have received additional funding and additional directive to grow what we're doing. So I think that deserves a round of applause for all of you and all of your work. And I think that's very encouraging, despite the important to acknowledge, excuse me, stress that we have. Also, we talked about lobbying efforts and that we can call our Congress. I was in DC a couple of weeks ago and was actually able to meet with Senator Kelly. And I just wanted to point out that if you are going to DC, any Arizona constituent can schedule a time. Every Wednesday morning, the senators meet with Arizonans who happen to be in town. So if you email a couple of weeks in advance, you can get a couple of minutes with the senator and talk to them. And I was actually able to meet with one of his policy leads over technology, and we talked for 20 minutes. 2 minutes with the senator, 20 minutes with the policy advisor, but it was fruitful. So I encourage, if you're in DC for a conference, for AAS or whatever's going on, schedule in advance and you can actually make a difference. I also wanted to talk about, so I wear multiple hats here. I work in Steward Observatory. I also work in Paramium Technologies, which is a company that spun out of the U of A. And I wanted to tie into what some people have made comments about, which is about sort of encouraging new scientists and new participants in this work. And I have a picture here of me as a grad student with a slightly different haircut, and how when I started early in my technical career, and my now partner in this company and I were graduate students working in Steward Observatory, and our advisor came to us and said, I'm sorry, this was like about May. He said, I'm sorry, I don't have summer funding for you. And so my co-grad student and I were frantic, and we kind of sat down and said, well, what can we do? We started making phone calls, and we said, well, you know, we have some of these really cool ideas that we think is worth funding. And we called some people at the NSF. We were able to get a little bit of money in a short time, like a month or so. They sent us $20,000. And then TLA helped us. Tech Launch Arizona was very helpful. And so this sort of pressure and stress that was put on us because our funding was cut actually led to the development of the technologies that led to the formation of this company, which has been very exciting. So there's always, I think, no matter what happens, it builds potential for us to be able to find new things. I also had a slide that I wanted to add that showed all the different undergraduates and some of the graduate students that worked with me doing the research at Steward that eventually turned into this commercial company. And so that's another sort of success path, is so many technologies that are developed here end up in the marketplace serving day-to-day needs of real people you and I use all the time. And I'll talk about that a little bit. So now I'll get through some of the slides I actually brought in. What I work on is ground stations for satellites. So all the data that's in space, the wonderful Earth observation data, astronomical data, lunar data that we've even talked about today, all of that data needs to get to humans on the Earth before it can be used, before we can see the pictures, before we can understand what's going on. And so the ground stations that receive the data is sort of the unsung hero, maybe not hero, but a critical block in the system that is not often talked about. So at Paramium, which is the name of my company, we like to say that we're selling the shovels for the satellite rush, because it's sort of the humdrum day-to-day infrastructure that's necessary, but that allows all of these wonderful technologies to grow. There are 11,000 satellites today, and by the end of the decade, there will be over 100,000 satellites. So this is a huge uptick in the number of people and machines trying to get data down to Earth. And most of the companies and institutions launching these satellites, including U of A, are not building new ground stations to bring the data down. So there's a huge mismatch between data trying to get down and actual bandwidth to get the data down. So that's what we're trying to serve. And as I mentioned, new technologies are coming online every day. Things developed here are now serving insurance companies and asset tracking and logistics, even home security systems, defense, of course. All of these technologies come out of the work that we do here, but also all of these technologies need to get that valuable data down to the Earth. And so that's what we work on. I'll skip a couple of things here. The technologies that were developed here in Stewart Observatory are what give Paramium, my company, our competitive edge. And if it wasn't clear, I'll thank again to Tech Launch Arizona and RII and various groups that helped us along the way to get from, 2 people with laptops in a lab to a company. And so these technologies, essentially what we've developed is we're designing an antenna that can be mass produced that doesn't just serve one specific satellite. The historical model is you have a space station or a satellite or a telescope in space, and it has its own ground station that was designed in parallel to function specifically with that one space object. But we're designing a multi-user shared infrastructure model where the Earth station, the ground station antenna, can communicate in multi-band with lots of different satellites. And that technology, as I said, was started here. Our antennas are the same all over the world, so there won't be, some of you I'm sure have worked with trying to connect satellites or CubeSats or other things to ground stations, and all the existing ground stations are unique. Each one is different from a different decade with a different frequency band, different comm protocols. Ours will be the same all over the world. Again, designed to switch quickly between lots of different users. And then we're also designing these antennas to have a digital back end. So we can import directly the raw data from the satellite or the telescope into a cloud server or a local server on the ground. Or we can actually process that in real time. We have a Jupyter notebook built into our platform. So you can upload custom code to process your data in real time and just deliver the information that you need. Also, our requirement that we require our engineers is that it has to be easy to use. We want our system as easy as scheduling a meeting on Zoom. We don't want students or research groups or small companies who want to launch satellites. We don't want them to have their own RF expert to establish the downlink connection, which is the case right now. If you want to launch a satellite, you need to have your own team of people to establish that ground connection, and we want to make that all easy. So, as I said, as easy as scheduling a meeting, you just select the satellite from your account, select the data destination, whether it's Dropbox or Drive or whatever, and then you schedule time on the calendar, and that's it. And we're also wanting it to be very flexible, so no long contracts, you pay per minute. We're even considering like a credit card option where you can just pay for 20 minutes and that's it. We want to make space data available to everybody, even an undergraduate. We have 10 employees, 2 labs, 3 Earth stations, and a data center and a manufacturing facility. And we have plans to grow a global network. As I mentioned, my partner, Kristen Davila, and I, we're graduate students together here. Our COO is a professor in the business school. So we're deeply indebted to the University of Arizona and all the space research programs. So we're grateful for that. And I also wanted to say that now putting back my University of Arizona hat, I would like to give back and bring back, all this technology and this user interface that we've developed here to the University of Arizona. The U of A owns 3 former radio telescopes that are one's at the Biosphere, 2 ones at the Tech Park at Rita Road, and 1 is in Colorado. And we want to be able to integrate this flexible software platform into those antennas. And we have a proposal into RII to be able to do that. So hopefully that will come through in the near future. But that will be compatible with the Multi-Mission Operations Center. And so that not only will we be able to manage the missions, but we'll also be able to use Arizona downlink capabilities. The Deep Space Network is totally overloaded and backlogged, I'm sure most of you know. And so we want to own that capability here in Arizona at the University of Arizona so that we have control of our own communication and our own data, and we're not relying on JPL or somebody else to give us free time. And that will also help, again, bring accessibility to undergraduates, graduate students, and new researchers. I'll skip over some other things here, but we're wanting to bring space data to everybody. And thank you all for all you've done for my career and for the world through all your technology development. Yes, question.
So I'm unclear, do you currently have ground stations in operation? And if so, how many satellites are you servicing? And if not, when do you plan to be in operation?
So we have some ground stations that we're using to test our software platform. They're not operational at the kind of bands that we're planning to serve. We're mostly downloading data from publicly available weather satellites and things like that. So we're in the process of building our specific ground station that we've optimized for the fast switching and mass production and things like that. So right now we have 3 that we're using with our software. But by the end of this year, we'll have our own constructed antennas that are optimized for this type of work. Thanks. Yeah.
Right. Is your data encrypted?
So we deliver the data directly to the server of the user. And so we do have end-to-end encryption, and we're able to implement encryption as needed. We're not targeting, right, as of now, extreme high-level security for government defense applications. We're targeting more academic, commercial level security. But in the future, we will. Yeah.
What kind of data rate can you handle? I'm thinking about hyperspectral IR, microwave, and LiDAR, and radar. The data rate is the issue we are facing with.
Yeah, so we're well aware of the bottleneck, and there are companies and groups who are taking photos of the entire surface of the Earth every day. And it won't be long before people are going to want real-time video streaming from space. And it depends on the frequency of communication and different things. I'd love to talk to you about it. But definitely data rate is a huge concern right now, especially with the infrastructure that's available. So I'm sorry I didn't give you a number, but we can talk about it.
Your own antenna, what kind of rate can you handle?
Yeah. Yeah, and like I said, it depends on if you're talking about KA band or X band or S band and different things like that.
Next time, curiosity. Yeah.
Yes.
You mentioned about multi-bands.
Yeah.
So you mean that you have S band, X band, K band, Q band, no, your service.
We don't currently have Q band, but that is in the plans.
So you have S, X, and
KA. Mhm. Yeah. Thank you.